For decades, missiles followed predictable paths. Radars could see them. Defenses could calculate where they'd land. But then came a weapon that broke those rules. It doesn't fly like a plane. It doesn't arc like a ballistic missile. And by the time it's detected, it may already be too late. This is the technology redefining modern warfare. This is hypersonic flight. And in this video, we'll break down, step by step, how hypersonic missiles actually work. To understand hypersonic missiles, we first need to understand speed. Sound travels through air at about 1,235 kilometers per hour. This speed is called Mach 1. Commercial jets fly just under Mach 1. Supersonic jets fly faster than it. But hypersonic? That begins at Mach 5, more than 5 times the speed of sound. At these speeds, something strange happens. Air no longer flows smoothly around objects. Instead, it compresses, heats up, and behaves almost like a solid wall. Flying at hypersonic speed isn't just about going faster, it's about surviving an entirely different physical environment. Traditional ballistic missiles follow a simple idea. They launch upward, exit the atmosphere, and fall back down along a predictable arc. This makes them fast but also traceable. Radar systems can spot them early. Defense systems can calculate their trajectory. Interceptors know where to aim. Hypersonic missiles were designed to break this predictability. Instead of flying high and straight, they stay lower, fly faster, and most importantly, they maneuver. That single difference changes everything. There isn't just one kind of hypersonic missile. There are two main types, and they work very differently. The first is the hypersonic glide vehicle. This system is launched using a rocket. But the rocket is only there to provide altitude and speed. Once high above the Earth, the glide vehicle separates and begins its real journey. Instead of falling straight down, it glides through the upper atmosphere, skipping and maneuvering at hypersonic speeds. The second type is the hypersonic cruise missile. This one stays inside the atmosphere the entire time. It uses advanced engines that take in air from the front, compress it at extreme speed, and generate thrust without carrying oxidizer. This allows sustained hypersonic flight, something that was considered impossible for decades. At the heart of hypersonic cruise missiles is a special engine. It's called a scramjet, short for supersonic combustion ramjet. Unlike jet engines, scramjets have no moving parts. They don't use turbines. They don't slow air down. Instead, air enters the engine at supersonic speed, mixes with fuel, and combusts while still moving faster than sound. This process only works at extremely high speeds, which means the missile must already be moving fast before the engine even starts. That's one of the hardest engineering challenges ever solved in aerospace. Speed isn't the only challenge. At Mach 5 and beyond, air friction generates extreme heat. Temperatures can exceed 1,000 degrees Celsius. Hot enough to melt conventional metals. Hot enough to destroy electronics. To survive this, hypersonic vehicles use heat-resistant composites, advanced ceramics, special shapes that spread heat across the surface. Some designs even allow the outer layer to slowly burn away, carrying heat with it. In hypersonic flight, materials science is just as important as speed. Modern air defense systems rely on prediction. They calculate where a missile will be seconds, or minutes, into the future. Hypersonic missiles ruin those calculations. They fly too low for early detection, too fast for reaction, and too unpredictably for interception. By the time radar confirms their path, there may be no time left to respond. This doesn't make them unstoppable, but it forces the creation of entirely new defense technologies. Hypersonic weapons aren't just about speed. They represent strategic deterrence, technological dominance, a shift in global military balance. Developing them requires mastery of aerodynamics, propulsion, materials, and computing, all at once. That's why only a few nations are currently capable of building them. And why the race to improve detection and defense has already begun. Hypersonic missiles aren't just faster missiles. They are machines that operate at the edge of physics. Where air turns into fire, speed becomes heat, and prediction breaks down. They don't just change warfare. They change how we understand flight itself. This is Techie Tales, where complex technology meets simple explanations.